Hi, how's it going, everybody? Good to see you. Raise of hands, how many people have heard of Qwik? Most of you. That's why you're here, right? Because you're curious. And how many have not, and this is your first? Okay. So hopefully we can blow some minds, etc. I actually, on the plane here, redid my presentation, so you guys are going to be the first people who will see it. So first, let me say hi. Hi, I'm Miško Hevery. I'm a CTO at Builder.io. We have this thing called Visual CMS. I'll talk about that maybe a little bit later. But yeah, I'm working on this thing called Qwik. I've done this thing called AngularJS, Zone.js, Clean Code Talks, and had something to do with Karma. So that's my previous life. And so the thing I want to talk to you about is kind of how we got here, how the problem is too much JavaScript, and what is a happy path to kind of go forward. So let's kind of look through this, kind of the history of how we got here. This is super important. So how did we do things in the past? Well, what we did is we had a server-side rendering technologies like PHP, Rails, etc. And believe it or not, this was actually very fast because the backend just served up HTML, and browsers are amazingly quick at turning HTML into the UI. And so this is essentially as fast as you can possibly go in terms of startup performance. Yeah, let's define that first, actually. I'm going to talk a lot about speed and being fast. But what I mean by that is how long it takes to start up, for the application to start up. In other words, when I navigate to a website, how long before I can start interacting with this particular website? And this is actually important to Builder because Builder has a lot of e-commerce customers. It's not just e-commerce, we have others as well. But a lot of e-commerce basically care about startup performance. So what we're really talking about here today is the startup performance. So rendering on a server is actually the fastest possible way to go. And it is extremely performant. And to this day, this is kind of the fastest way to have the startup performance. But at some point, we're like, yeah, but it's static, right? Like, we need some interactivity. And so we had this thing called jQuery and MooTools and a bunch of other things. And the whole point of these things was to add interactivity to your page, right? Like, yes, it's nice that the page shows up very quick, but I really want to do something useful. Like, I don't want to, every single click shouldn't be a round trip back to the server. You know, that's not a very good experience. I want to be able to drag things, move things, hover on things, you know, have animations and so on and so forth. And really the only way to do that is to have some kind of JavaScript on a client. And so we had jQuery, and the important thing to understand about jQuery is that jQuery really only augmented what the server created. And therefore, there was always relatively little amount of JavaScript with jQuery in there. And so this was extremely performant. And what the issue with this particular approach is that the rendering and the interactivity were separated into two separate buckets, right? So the rendering of the HTML was done in like PHP or Ruby on Rails or something like that, which was one language. And then the interactivity of jQuery was done in a separate language, which was JavaScript. And that kind of clashed because oftentimes you would have to develop the same thing twice. Like, for example, form validation. Or let's say you had a form that has person's contact info and you wanted to add a new phone number. So the code to render a new line with a phone number had to be implemented twice, once in the jQuery PHP, and then again in jQuery, right? So once in the backend language, once in the front-end language. And so this particular development style was kind of slow or error-prone, and it caused duplicate logic. And this is the primary reason why we kind of moved to the current way of doing things. And in the current way of things, by the way, before we go to current, I want to point out, though, that this is so performant to this day. This is, for example, how Amazon does things. And every time there was actually a tweet that Amazon did saying, like, we try to look at other technologies such as React, and we kind of realize they're just not fast enough for us. And so let's kind of look into where we end up today and why it is not fast enough. So the current movement really that happened was all about the developer experience, right? We want to make DX better. Basically, this red box right here, that we have to do everything twice, two different languages, they don't mix, etc. We wanted to kind of get away from this. And so a current set of frameworks, whether it's Angular, Vue, Svelte, React, pick your favorite, they all essentially work the same exact way. And the thing that they brought together is the mental model of a component way of developing your application, right? So you have components all the way up and down. Everything is a component. And more importantly, it's all JavaScript, right? Whether the code runs on a server, who pre-renders stuff in HTML, or it runs on the client, it's all JavaScript. We only have to write everything once. People love the developer experience here. Now, within these frameworks, different frameworks will argue that they have a better developer experience than the other, and it's kind of why we have kind of the factions of people saying like, I love Vue or I love Svelte or whatever you have. But if you zoom in on high enough level, you realize that all of these frameworks essentially work the same way. And fundamentally, they provide essentially the identical developer experience. And so the big thing here is it's a unified mental model, right? It's a fast development in scales and complexity, in terms of throwing people at the problem, not necessarily scaling and complexity in terms of the startup performance. And the key thing here is that render and interactivity are united into a single framework. However, the application runs twice. And this is kind of the source of the problem. We're going to kind of dive into this deeper. Basically, application runs once on a server and once on a client. And I'll show you kind of what I mean by that. And so we did this double running of the application. We gave it a fancy name called hydration. And yeah, hydration is both the solution and the problem. And so we're going to kind of dive into it. So where are we going in the future? Well, I think in the future, people are catching up to the fact that we need performance, right? But we don't need performance at the expense of DX. Like, we want both. We want a really good DX, and we want performance. In other words, we want the performance of server-side rendered HTML, but we want the developer experience of the current component model systems that we currently have. And so there's few frameworks in this category. Google has one called Wiz, and it's been around for almost a decade, and it actually runs Google Search. Every time you use Google Search or you use Google Photos, you are actually using Google Wiz. And one thing I will point out is that is amazingly fast. Right? To me, it's amazing that when I want to spell check a word, the fastest way to spell check is to actually type it into the Google and have it back. And it's not just trivial. You think it's just a format, et cetera. It's not trivial. Like, if you search for a movie, you get a complicated movie carousel. If you put an equation, you'll get an XY chart of the equation. There's a calculator and all kinds of things in there. So it's quite a lot of interactivity, and they can't really rely on hydration because that would be slow. And the thing you'll notice about it is that at no point are you in a situation where, as a user, you can click on something before Google is ready. And that's kind of the key. And I think part of the reason why so many people come to Google is because, well, it's fast, right? eBay works on a framework called Marco, and in the next release, version 6, they're going to have resumability. And so it's kind of the same exact philosophy. And of course, I work on a project called Qwik that kind of tries to bring the same exact thing as well. So I think the future really holds somewhere in the lines of, like, I want the developer experience that I am used to, and I want the speed that we used to have and we have somehow lost in the process. And so the key thing here is that the interactivity and code, et cetera, it's all united into a single framework, right? So we have a unified model, it scales in complexity, and application only runs once. That's the key thing. So let me show you what I mean by that. Okay, so what is hydration? So hydration is a workaround. So let's start with what the page looks like. First, browser, you send HTML to the browser, right? So if you go back to kind of the second generation where we have something like Angular or React or Vue, you start with HTML, and HTML is usually just a blank index.html that doesn't really contain anything, and it contains just a little anchor where the application can bootstrap. So the blank page shows up, it's shown by a rectangle here, right? It's blank, there's nothing in there. And then the blank page says, go download JavaScript, so the browser starts downloading JavaScript. At some point, the JavaScript that you downloaded is really the application you have written, and as the application executes, it builds up the DOM, and it renders the DOM, and finally, the application shows up. Right? So this is the experience that you have today. Now, these are essentially what we call a single-page applications, and oh, by the way, it's at this point where you're ready to click on something, right? So interactivity shows up at this particular point. Now, when people looked at it at first, they said, this is nice, but I really don't like this emptiness at the beginning, right? Like, we need to do something about this empty blank page that shows up when you have a true single-page application. So what can be done? Well, what we can do is we can pre-render it on the server. And so what you see now is that this HTML is bigger, right? Because the original HTML was super small because it's just a blank page. Now we send larger HTML that actually has your application. And so now, when you first navigate to the page, you immediately see the website. And so that's an improved user experience because the user can now see. The problem is you can't click on this, right? This is inert. This is dead code. And so the next thing that happens is, well, it appears faster, right? And then you start downloading JavaScript, you execute application, you do the rendering, and then finally you reconcile, which is basically a fancy way of saying we will re-render without destroying the existing DOM. We will try to reuse the DOM as much as possible. And at this point, it is interactive. You can click on it. And so here's the bizarre thing. You're actually slower than the previous case, right? Because you have sent a lot bigger HTML than you were originally. So the application appears faster because visually it shows up quicker, right? Because previously it was just a blank page. But actually it took longer to actually get it interactive. And if you don't believe me, what you can do is you can actually send an HTML for a completely different page, right? That has nothing to do with your application. And when this executes, it will still re-render the page to the correct site. In other words, this what we call reconciliation, rehydration, etc., is just a fancy way of pulling just a render. And what we're doing here, the only difference between the render and the reconcile, is that in the reconcile's case, we are attempting to reuse the DOM node, right? If the application has already the same structure as what we expect, great, we'll reuse it. If it has a completely different structure, we'll still delete it and create a new one. And so in the end, even if you delete this bit over here, the same exact stuff is happening. And if you think about it, there is a duplicate amount of information that appears over here, right? So this HTML and this JavaScript have duplicates. They have the same strings in both sides. They have the same code that generates the same structure in both sides. One sits in the form of declarative format. The other one is in the form of JavaScript. But there's a huge amount of duplication that's happening over here. And so this is kind of the current status quo. And I'm going to argue that this current status quo is slow. If you go on Google page speed, so Google cares a lot about performance of the websites, and so they created something called Core Web Vitals, which basically looks at the Chrome is instrumented and to observe the user as they're navigating different sites. And Chrome sends anonymous information back to the Chrome Web Vitals website, where you can then query this information and see how different sites perform. And then one of the things that Google did is they basically created categories. They said we have a green, we have yellow, and we have red, right? Saying green is excellent, we love it. Yellow needs improvement, and red, like, you're not doing very well. And the interesting thing is that most people, most websites, most companies actually end up in the red. Only the companies that try really, really, really hard, like Amazon, actually end up in the yellow. And as far as real e-commerce websites that actually have money flowing through them, I have never seen one in the green, right? So why have we kind of gotten ourselves into this situation where even the people who should care, like Amazon, and I'm not saying that they should care, they actually do care a lot, and they spend a lot of resources at this particular problem. Even those folks have a hard time getting to where we are. And my argument here is that the way we built our tools through historical reasons, we ended up in a place which is suboptimal, right? And it's not that we wanted to end up over here. It's just, it's always history. The answer is always history. If you look at history, how we got there, it makes sense. Otherwise, it's all bizarre. So let's look at this again from the point of view of resumability, right? So on the top, I'm showing you what happens today in the hydration, right? You have HTML, then the page shows up, then you have JavaScript, execute app reconciliation, and then finally you can click on it. So let's look at it from resumability point of view. So you still have the same amount of HTML because you have to paint the site. And the moment HTML shows up, the site shows up. So that's great. So you have interactivity. Now, the interesting thing about resumability is that this is the point where the site becomes interactive. So inside of the HTML, there is a super tiny amount of JavaScript, which we call quick loader. Different frameworks use different strategies. The Wiz uses JS Action, which is actually open source. You can check it out. It's super tiny, usually about a kilobyte. And it registers the listeners so that the moment you get to this point and a user clicks on something, the event is captured and processed. So you don't have the problem that you have on the top, whereas that if you click anywhere in here, the event is just lost. It disappears. So we have a huge improvement in speed in terms of how much faster the page shows up. So the next step is we download JavaScript. And that's it. We're hydrated. The application is fully running. I know what you're going to say. It's like, well, wait a minute. You made the JavaScript smaller. Like, what happened over here? Well, remember all this duplication that I talked about? How like you're sending the information twice, once in the form of HTML, once in the form of JavaScript? What if the framework knew how to remove this duplication and recognize the fact like, well, you've already sent it in the form of HTML. Why would I send it again in the form of JavaScript? And so the reason why this particular box is smaller is because the framework can remove the duplicates and send you with a lot less information. Now, then you're going to say like, yeah, but what about the execution of the application and reconciliation? Like, don't you have to do that? The answer to that is no, because of resumability. And if you think about it, not only we don't do that, we actually cannot do that. Because there is actually a huge amount of JavaScript that's missing, right? In order for the app to execute, you have to have the whole application present. But if you have removed a whole bunch of things through, removing the duplicates basically because you already know that you don't need to run it on a client, you cannot even execute the application wholly to cause a rendering or reconciliation. So through this clever trick called resumability, we can skip these particular parts. And so what you end up with is you end up with HTML, the page shows up, you can immediately click on it, and if you manage to click on it before the JavaScript shows up, then you'll have to wait slight amount of time. But as soon as JavaScript shows up, it's instantaneous, right? And of course, we download the JavaScript immediately. So as soon as the page renders, immediately JavaScript interacts. So there is a super tiny window when it is possible for you to click, and you might have to wait a little bit. But as soon as this window is over, no delay in interactivity. And as you can see, the improvements here are pretty significant. How significant? Well, we took our website, Builder.io, and we rebuilt it using Qwik. And what you see on the right-hand side is Qwik. On the left-hand side, you see Next.js. And the thing I want to show you is just how fast the page goes gray. When the page goes gray, it means JavaScript is no longer executing. There's nothing to do, right? The page is finished. Versus on the left-hand side, you see that the Next.js site is taking upwards almost 8 seconds to reconcile everything, execute the JavaScript, download the JavaScript, and process everything. And it's a huge difference in performance. And of course, as you go on a mobile device and slow networks, this disparity only gets worse. Now, I'm not trying to pick on Next.js over here. It turns out if you use any of the existing technologies, whether it's Next, Angular, Svelte, Vue, etc., they all have the same particular problem because they all are written with single-page applications in mind first and use hydration as kind of a trick to get everything up and running, right? So what Builder does is we actually have lots of different customers that use us, and they use us with lots of different technologies. Angular, React, Vue, Svelte, you name it, we have a customer that does this particular thing. And what we see across the board consistently is that they're having a really hard time to get out of the red zone in terms of Core Web Vitals metrics. And it all comes down to the amount of JavaScript that's being executed. Okay, so is this really a problem? And I'm going to try to convince that the answer is yes. So Google Web Team has collected lots and lots of statistics that basically says, yeah, it matters. Every time you make the user wait is time where the user gets frustrated and at some point it says, you know what, screw it, I'm leaving the site. Right? And especially if you have landing pages where you're interested in conversion, where you're interested in capturing the user's intent or the user actions, the problem becomes that you get the people to come to your website, through some kind of marketing, and then once the person is there, they're like, you know what, this isn't working for me, and I'm leaving. Right? I had an interesting experience, actually. I went to Europe and to a conference, and I didn't want to pay, so I have T-Mobile, and T-Mobile gives you slow internet kind of for free, and then you can pay for a little more money, and you get yourself fast internet. Because I was just at the airport and going to the conference center, I figured, while I'm in a taxi, I don't really need fast internet, it's fine. And so I was in a taxi for about half an hour, and I, just for fun, started visiting pages. And it was interesting to see how the web became essentially unusable. But when I went and visited our websites, either the Qwik site or the Builder.io website, the interactivity was there immediately. And the difference is, again, in the amount of JavaScript and amount of code that has to be downloaded and executed. And you can see this in the amount of JavaScript over time, right? So this is a graph that shows the amount of JavaScript that's being sent, an average page, how much JavaScript it has. And you can see that this is just going up, up, and up. And I don't think this is going to change. Like, I'm not here telling you that you need to have less JavaScript. I'm here telling you that we're doing it wrong in the sense that we are forcing all the JavaScript to show up early. We are in the world where, imagine you went to YouTube and you wanted to watch a video. And YouTube would say, like, OK, before you can watch it, I need to download the whole video ahead of time. Right? That wouldn't work. Instead, what actually happens is the YouTube will just go and buffer a few seconds worth of video, and as soon as few seconds worth of video are downloaded, the video starts, and you are watching and downloading the video at the same time, right? You are streaming. But our apps don't work that way. Our apps don't stream, they download, right? Like, you can't do anything on the page until all of the code associated with the page downloads. And so the thing I'm trying to push towards is not write less JavaScript, but really have this streaming mental model. Okay, so let's talk about Qwik for a second. Is the framework we work on, and is the framework that kind of embraces this to its heart. And there's two parts to it, resumable and progressive. And so the best way to explain resumable is that imagine you have a virtual machine. The cool thing about virtual machines is that you can navigate to a page, you open up a virtual machine in your host computer. Let's say you have a Mac, you open up Linux, you boot up Linux and you watch the boot up process go through, then a login page shows up, then you log in, open up a word processor and you start typing a letter. And at some point you save the virtual machine, right? You can take the saved file of the virtual machine and send it to your friend. Your friend can open it on a different machine and they're exactly where you left off. They don't go through the boot up process, they don't go through the login, they don't go through opening the word processor, they don't go through writing the letter, they're literally where you left off and they can just continue. And so the same exact thing is going on with resumable systems, right? We execute the application on a server as far as we can, we pause it, ship it to the client, and then the client just continues where the server left off. And the other bit is this idea of progressiveness or streaming, right? Existing systems force you to download all of the application code upfront, whereas what you really want is you want to just download the code as you navigate the application, as you keep using it. And so I think we're in the precipice of a new kind of world. We have the existing frameworks that are replayable, that have this hydration problem. And then there's a new set of frameworks coming online that are resumable, that are frameworks that say, you know what, we can do better on the startup performance, significantly better. And we can keep the same exact developer experience that you're used to. Okay, so everybody wants a demo time, right? Okay, so let me show you what I mean by streaming. So every application has to have a to-do. Every framework has to have a to-do demo. And what I want to show you is, let's go to the network tab. So here's our network tab. And notice there's a piece of JavaScript here. But actually, this piece of JavaScript, if you zoom in on it, is actually Vite. I'm running in a dev mode. And so I'm going to say, pretend Vite is not here. In production mode, Vite is not part of it. It gets compiled away. So I'm going to just filter it out. And when I do that, I'm going to show you that there's no JavaScript. Now, we're running in the dev mode. And dev mode means that we break everything up in a separate file, etc. That's not actually how it works in production. In production, you put things together so you don't have waterfalls. You prefetch things eagerly, etc. But in order to demonstrate how the system works, I'm showing it to you in a dev mode. Okay, so you navigate to a page, and no JavaScript is present on the page whatsoever. And the thing to notice is that as I start interacting with it, JavaScript shows up. What happened to my JavaScript? Where is it? This demo worked. Literally, it's running, but where is the JavaScript? Oh, here we go. Okay, sorry, I don't know what just happened. Okay, so here's our demo. And as I start interacting, JavaScript shows up. And not all of it showed up, just some of it. Then I hit enter, more JavaScript shows up. Then I delete an item, more JavaScript shows up. And as I'm interacting with different parts of the system, more and more JavaScript is showing up. And this is what we mean by streaming, right? So let's add an item. Let's refresh this again. Let's say we do new item. And then let's click profit, and let's only show the active item. So the profit is hidden, right? Now, the best way to explain resumability is basically this trick, this demo. So we see that we have a container, and currently this container is running. what we can do is we can pause it again. And by pausing it, the system serializes its state. We can take this system then and copy the HTML, go into a separate tab where we have nothing, edit as HTML, and we're going to paste it in. Now, if you did this to an existing framework, you can do this. You can copy HTML, and you would see something, but you would have an inert application. Right? This wouldn't be working. And more importantly, if you did this, and then you would try to interact, if you could somehow re-execute or re-bootstrap the system in the existing frameworks, you would reset the system back to the original state, right? Remember, hydration isn't really hydration. It's really just, opportunistically try to reuse the DOM if you can, otherwise throw it away and rebuild a new UI. But what's cool about it is, here, the system actually continues running. Of course, the demo doesn't work. What just happened? Because I forgot to hit enter here. Duh. You pause this thing. Now the container says paused. You grab the outer HTML. We go to the page here. It's really messed up. Okay. Helping. Sorry. Let's try it. Okay. Go here. Okay. Grab the HTML. Paste the new HTML, right? So we have a to-do application here. But because it was paused, we can now go and click all, and we can see the missing bit, the profit that came from the other page, right? So this is what we mean by resumability, is that at any point, the application can be paused, moved to a different location, like a different tab, and then continue executed where it left off. And you say, well, that's a kind of a weird party trick, like that's cute, like, but why would you use it? This is actually how the application gets from the server to the client, right? So on a server, the application runs, it kind of gets bootstrapped. We, just like in a virtual machine, we save it at some point by serializing everything into the HTML, because the HTML is kind of the way of transferring the data across. And then we send it to the client. And just like in real virtual machines, you can send your virtual machine file to 100 different friends. The same thing happens here. We don't have to have the server. We can just store the information on a CDN and then make sure that the applications start up very, very fast. And so that's kind of the idea behind resumability, and the idea that you want to have a system where you are streaming the application rather than upfront downloading it, and you get a much better performance that way. So let me show you now another of my favorite demos. Again, I'm going to clear the Vite, so Vite is not here. And I'm showing you that this is a page that has no JavaScript. All this page has is a bunch of text, and then on the bottom there is a clock. And notice this clock updates every 1 second. And notice when the clock came into view, the JavaScript showed up. So let me show this again. So no JavaScript. When I scroll the clock into the view, the JavaScript associated with the particular clock shows up. Now, the thing I want you to think about is like, well, how would you do that if you were to build it yourself? Like, let's say you wanted to get this thing working with the existing systems. How would you do that? Like, what would you have to do? And this is kind of my point here, and I'm going to show you how this is done in Qwik, is that we want to be in a world where without thinking, without really putting some effort into the thinking about how I'm going to design the application, the natural thing to do is actually the correct thing to do, and it's the performant thing to do, right? And this is not what happens with existing frameworks. When existing frameworks, if you just keep writing code, you'll end up in this huge mess that's large, slow, and takes forever to start up. And then you have some kind of a task force that goes in and tries to mitigate it and tries to optimize things and make situation better. And usually there's a very limited things that they can do. So Qwik's philosophy is like, no. The most obvious thing, the easiest thing you should do should produce the exact perfect outcome. And when I say perfect, I'm actually talking about this idea that you shouldn't be downloading any code that you don't strictly need, right? So in the ideal world, the only code that should download is the code associated with the clock and maybe the framework itself, and then nothing else, right? The other components shouldn't load. And actually, this particular demo is running in Qwik City, and if you notice, there's all these comments that say QV. You can actually see that there's quite a lot of them. through it. Every time you see a QB comment, there's actually a component that was done on a server because this is Qwik City. There's a component for the header, there's a component for the footer, there's a component for the head part of the UI, for routing, and for all kinds of other things. But none of those components should be downloaded to the client when they're not actually needed, right? So really the only thing that we need for this particular demo is just the code behind the clock and nothing else. So let's kind of look at the source code behind this. So you have standard routes. So in here we have just route/clock/index.tsx. This is what makes the clock shows up at this particular route. And the way Qwik works is that you export a default component. Now, if you're a React developer, how many people have done React? Good few of you. Okay, if you are a React developer, you look at this code, you should be like feeling right at home. This is exactly what you're familiar with. The only difference here is that we have this function called component $, and you'll see $signs all throughout. What the $sign means is this is a potential place where lazy loading can happen. And just like React has these use methods, and there are special rules about using the use methods, you can't just use them anywhere. There are special rules about these $signs that basically say, like, look, because serialization happens, because lazy loading happens, there are certain implications in terms of like asynchronicity and what can be serialized, etc. But once you use these rules, they're pretty natural to use. Now, the other thing is that these $signs are actually part of the API. So it's not like you can forget to put them there, because TypeScript will scream at you saying like, oh, there's a, that API doesn't exist. And so what you're going to see here is that this is a component. We just create an array here, and basically we create a whole bunch of li items from the array, and then we put a clock on the bottom. And the whole purpose of this component is really to put the clock below the fold, right? So this component doesn't do anything, and again, if you're a React developer, you shouldn't see anything different. The only thing you'll see different is that we have an on-click $sign, and so in this particular case, we're just going to say we're going to print out the test. So let me show you how that works. So if I refresh the page, network, there's no network present. I should be able to click on this title. When I do, the console prints out the test. And if we go to the network tab and see what actually downloaded, we're going to see that the only code that downloaded is really just the console log test. And that's kind of the big difference here. If you were to do the same exact thing in any other framework, you would have to download the framework, download the full application, execute the full application, build up or reconcile the DOM, and then the application would be ready for interactivity. So in the simplest possible case of just console log, you're still downloading, tens, if not hundreds of kilobytes worth of code that has to be downloaded and executed. Whereas Qwik has this idea of being absolutely surgical about it, right? And so in this particular case, literally the only thing that downloaded is the function that says console.log, because, well, that's what you told us to do. Now, this is a trivial thing. A much more interesting bit is what happens when you scroll to the bottom over here to the clock. So let's look at the clock. So here's our clock. Again, we have a component $sign. We say that the clock needs to have a particular style information, right? So we have styling. We create store. So in order for resumability work, you have to be reactive. And so use state is not reactive. So you have to use something equivalent like use store, which is actually a reactive system. Then we have a client effect. The only thing, the difference you would see here again is the $sign and the word client. The client has a special meaning, like it's a hint to the developer in terms of where the code runs. But in here, you would do the basic stuff, right? You have an update function that knows how to compute what time it is in terms of angles, right? So this computes the angles. And you invoke the update function every second, and you return a cleanup function itself. Again, if you're a React developer, you'd be like, yep, that's exactly what I would do in React. There's nothing special in here. Just for fun, we print render clock, and then we have a JSX associated with the clock in terms of how to render it. Right? So let's have a look what actually gets downloaded to the client. So again, we refresh the page, nothing, no JavaScript, right? So when I scroll, the first thing that downloads, let me actually make this bigger. The first thing that downloads is this closure that knows how to update the clock, right? So this use client effect that was right here is what's being downloaded in this particular section. And so this use client effect knows how to go and update the clock every 1 second. And of course, in this particular case, because we actually have to do rendering, we have to download the framework itself. So notice, again, I go here, when I clicked on this button, only the console log showed up. When I went to the clock, not only did the effect showed up, but also the framework, because in this particular case, we actually had to have the framework. So it was a more complicated case. But again, notice how surgical the system is. We're not downloading everything. We're really just downloading the thing that you absolutely have to have. So now let's look back at the source code and let's notice what didn't download. Right? First of all, we didn't download any of the components, none of them. We didn't download the styles because the system understood, like, oh, the styles were rendered at the server, and therefore you don't need them on the client, so there's no need to bring styles in again because they're already there. We didn't rerun this piece of code because, well, we already know what the store is, we serialized it. We had to run client effect, and so the question is, when should you run client effect? With existing systems, the answer is pretty trivial. Like, well, you run the client effect during hydration, right? It's kind of obvious. Where else would you run it? But Qwik doesn't have hydration. So when exactly should you run a client effect? And so we kind of thought about it for a while, and we decided, actually, the most useful time to run it is when a component becomes visible, because usually a client effect is something to do with like changing the component's state. If the component isn't visible, why even bother running it? So the default behavior for client effect is to run it when the component becomes visible. There are other options you can pass in. You can do it eagerly, etc. But that's kind of the most obvious one. And notice we didn't even download the JSX associated with the component, right? So the clock is running. Let me show this again. The clock is running. We downloaded the client effect because, like, we have to download that piece of code because that's the piece of code that goes and updates you every 1 second, right? So there's no way around that. And we need the framework because that's what does the magic, which is about 22 kilobytes, by the way. But nothing else got downloaded. Not even the JSX. No other templates. Nothing else, right? And that's the thing that I want to point out is that we need to have frameworks that just do the right thing out of the box without any sort of effort on the part of the developer, right? It's not like this particular example was contrived in some way where I was like, okay, let's do some special APIs to kind of boot things up just the right way to kind of get the system going. It's like, no, as a developer, this is like the obvious thing to do, and I just did the obvious thing, and yet I got the outcome that is not obvious, right? It's the outcome that you really want, and it's kind of what you want, right? And the other thing I wanted to really drive home is how surgical Qwik tries to be, right? Well, we don't try to prefetch. We don't try to download way too much code. We really look at the whole situation and say, like, what is the absolute bare minimum that we can download to get away with this, right? And it's on a whole new level because, you know, normally, let's say you have a closure like this. Great. How do you lazy load that closure? Oh, well, now you have to refactor it by moving it into a separate file, create a dynamic import, but then somebody has to run the dynamic import, so you can't just leave it behind. And very quickly, you will realize, oh, and also, this closure closes over the store. So if you move it over to a separate file, how are you going to pass the store information to it? And so very quickly, you're going to realize that, like, if you wanted to lazy load this particular code, you would run into some really complicated problems. And you're going to look at it and be like, you know what, it's just not worth it. I'm not going to do it. And this is kind of what happens to our existing frameworks is that there's just so many, it's just not worth it, therefore I'm not going to do it bits that we just end up in this particular case. Okay, let me show you a few other demos. This is basically how existing systems work, right? You have a HTML shows up, it's not interactive, browser downloads the JavaScript, and then it starts executing, and as it's executing, it's making things interactive, and now that everything is blue, you're welcome to interact with the application. The thing that's different about Qwik is that you can go and interact with any component. Let's say I interact with this component. Only that component's code gets executed. Notice I didn't say hydrated, because there's really no hydration happening here. Only that component's code gets executed. But what's more important is the fact that neither the parent nor the child component had to be present. The system didn't force me to also get the parent or the child. And this is super important because what happens in real world is like you navigate to a new route, you grab the root component of the route, and guess what? You're getting everything that's below it. Right? And the other thing to kind of understand is that even if you try to do lazy loading in existing systems, let's say you put a lazy loaded boundary between here and there, it doesn't really help because the system has to eagerly download the lazy loaded boundary because that component is visible, and therefore we need to execute the code associated with it so we can figure out how to make the stuff work. Let me show you another demo which I think is cool. So one of the things that I want to show you is that normally when you want to interact with the page, this is a very simple page. We did this together with Cloudflare. Normally when you interact with the page, you can't interact with the page until hydration happens. And you can't do hydration until HTML finished loading. And so in this particular demo, we have intentionally slowed down the body of the page. You see how the page is slowly loading? And so the HTML isn't finished until the bottom shows up. But notice, even though HTML isn't finished, I can already interact with the page. Right? And so this is important because it shows that, when I had the original kind of a diagram showing you how it is quicker here, well, guess what? This ability, this clicking ability, can actually be moved even further up the HTML stream. So before the HTML even is fully shown up, you can already interact with different parts of the page. And I think that's pretty cool. Now, the other thing I want to show you is that we actually have what we call containers. And I think the best way to kind of show you is that every single one of these boxes actually came from a different worker. So multiple servers collaborated on producing a single HTML, and it works as a micro front end. This is kind of an advanced use case. We can talk about it later. But here's an example which I think is pretty cool, and then I'll let it be, which is as this page is showing up, different images are showing up, so the backend is streaming, and it's doing it kind of slowly. I'm going to refresh this again. But even so, I can already interact with the application, right? So this is just showing up, again, the idea that before the page is even fully shown up, you can already interact. This clock is telling me that I'm finished, so I am going to be hanging around. I have some stickers to give out. Feel free to chat with me. I'm happy to chat about it, talk about it, etc., and happy to answer any questions. Thank you for listening.